Welcome back, Leo Lions. This is Mrs. Markin with today's lesson over multiplying polynomials. So we're going to start today taking a monomial. So remember, a monomial is one term, and we're going to multiply it by a polynomial. Polynomial simply means more than one term. And it could be actually just a monomial as well. So polynomial could be mono, bi, tri, or polynomial. So a lot of our exponent rules that we discussed in the last bundle will come into play here. So when we multiply a monomial and a polynomial, we're going to distribute that monomial to everything inside the parentheses, and then we also have to apply the product rule. So the product rule that we learned was anything with the same base. So let's say x to the b power times, like I said, same base but different power, so x to the a power. Then we keep the base and we add the exponents. All right, so just to remind you that rule. So when we do x times x, those both have powers of 1, so x times x will be x squared. And then the x also goes to the 4, so we're going to write that as 4x. The coefficient always comes first. All right, another example, when we distribute this 5m cubed, so remember, we will distribute it to everything. Multiply your coefficients, so 5 times 3 is 15. And then your variables, m cubed, m squared, that is what we would add, so m to the 5th power. Distribute to the minus m, so we're going to have minus 5 times 1 in front of that m, so minus 5. And then don't forget here we have m cubed times an m. There's really a power 1 there, so now we have 4m's. So minus 5m to the 4th. And then the last one we multiply by is that negative 7, so negative 35 is 5 times negative 7. There is no variable on the m, so it just stays exactly how it is in that 5m, so minus 35m cubed. Notice nothing can be combined from here because all of our terms have different exponents on the variables, so m to the 5th, m to the 4th, m cubed. If any of those were the same, then keep in mind we learned that we can add and subtract, and you'd want to simplify as far as you can, okay? So I will start off doing a couple examples with you. What I will probably do is go down the left side, so doing the odds, and then leave the right side, the evens, for you to complete on your own. So very similar to that first example we did, k times k is k squared, minus k times 9, we get minus 9k. Negative 6p times p to the 4th, so we get negative 6. P to the 5th, there is a power of 1 on that p. And then here, be careful with your negatives. Negative times a negative, this is going to switch to plus 48p. Negative 4g squared, and we're going to distribute that. So negative 4 times 2, we get negative 8. G squared times g, so we have g cubed. And then negative 4g squared times 7, so we're going to get negative 28, and then g squared stays out as it is. Next one, negative 3n times our n squared, so we get negative 3n cubed. Negative 3n times negative 2n, so it's going to switch to positive 6, and then there's 2n, so n squared. And then negative 3n times 8, so we get negative 24n. So hopefully you have caught on now to this pattern. We multiply coefficients, but then we add the exponents on the variables. Now be careful here. We have p squared, q cubed, times p to the 5th, q squared. So we can only combine our p's and our q's together. So the p, we have squared and to the 5th, so we get to the 7th. Q, we have q cubed, q squared, so we have a total of 5 q's there. And then this also gets distributed to this minus pq. So I like to think of, is it going to be positive or negative first, and then deal with your exponents. P squared times p, so we get p cubed. Q cubed times q, so that we have 4 cubes, q to the 4th. Okay? The only way we could combine those from there is if those variables on the, or those exponents on the variables are the exact same. So we can't combine those. Let's do it again. So we have negative 10 r squared, so we'd have 4 r's, and then the s squared has to stay. Then 5r squared s squared times 3rs, so we have positive 15. R squared times r, so there's 3 r's. And same thing with the s squared times s. Oops, that should be s cubed. And the last one, 5 times negative 4, so negative 20. Then we have r squared. Now we have s squared, so the s becomes to the 4th power. All right, one more kind of intense one like this. So negative 7 times 9, we get negative 63. C cubed, c squared, so we have c to the 5th. D squared, d to squared, so d to the 4th. And then let's distribute it to the second term. Negative times a negative, so we get plus 28. C cubed times c, so we have c to the 4th. D squared, d to the 5th, so d to the 7th. Add powers on the like bases. Now, starting, and here I would like you to pause the video, see if you could do all the even numbers on the side there and get those correct. Distribute and then simplify. So here we are going to end up combining like terms after we distribute. Now we only distribute this negative 2x to the terms that are inside the parentheses. So be careful. It only goes to the parentheses it's touching. So we get negative 6x squared. And then negative times negative, so we'll get positive 8x. And then that plus 7x on the outside stays as it is. It does not get distributed there. Now, we have two like terms, so we can simplify this. The negative 6x squared stays, and then 8 plus 7, so we have 15x's. Okay? Again, I'm going to leave everything on the right side for you to complete as practice problems, so I'm going to flip to the next page. And we're going to do it again. So we'll distribute first. Here we are actually distributing twice. So the y to the y, we get y squared. Y to the 4 plus 4y. Then negative y times the y, so minus y squared. Negative times negative, so plus 3y. And then this minus 9y on the outside just stays as it is. Now we have lots of things we can combine. I'm starting with the highest power, so y squared minus y squared. Well, that's 0. Those end up canceling out completely. Then we have 4y plus 3y, so we now have 7y. 7y minus 9y, so we get negative 2y. Simplifies down to one term, a monomial. Let's do it again here. Be careful. Now we have multiple variables, so we'll do 2 times 6. The x comes before the y, then 2 times negative 4. X squared is there, and then we have y times y, so it's going to be y squared. And then everything else on the outside, I'm going to keep it as is, and now let's see what we can combine. Highest power is this x squared, y squared. We have a negative 8, and we have a plus 13. Those both have x squared, y squared on them. They have the same variables, same powers. So negative 8 plus 13, we get 5x squared, y squared. Variables have to come next, so I'm going to jump to the 12xy. There is no other term with xy, so we write it as plus 12xy. And then that negative 6 is a constant by itself, so minus 6. There it is simplified. All right, I'm going to keep going. I'm going to do one more with you because some of these do get a little intense. They're long, lots of steps involved. But if you take it one step at a time, we should be okay. 3v times negative 2, so minus 6v. Then distribute a positive 3. Positive 3 to the 2v. And a positive 3 to the 1. And then last one, we're distributing it again. Negative times a negative. So this switches to a positive 15, and then v times v, so v squared. Negative times a negative, so we get negative 9v. So there was the first step. We distributed all of those terms that are touching the parentheses. Now let's go through, find like terms. The highest power we have is v squared. So I'm going to go through, find all of my v squareds. And notice I am highlighting the signs in front. So 21 plus 3, we have 24. 24 plus 15, so we have 39v squared when we combine those three terms. Next, I'm going to go to just the variable v, so negative 6v plus 6v. Oop, those cancel out. They're gone. But then we still have that minus 9v, so we'll have negative 9v. And then we just have one constant here. There's no other numbers by itself, so we'll just write it as plus 3. And there is our simplified polynomial. All right, again, I'm leaving the rest there for you to try out and see if you can figure those out on your own. I'm going to jump down to these geometric applications. So we're going to find the area of this trapezoid. First of all, if we don't know the formula, it'd be important to know that the area of a trapezoid is 1/2 times the height and then times the bases added together. So base 1 plus base 2. The bases are your parallel sides. So those are your bases. And then the height forms that 90-degree angle. So the 4x squared. So let's plug in everything we know. So 1/2 times the height is 4x squared. And then in parentheses, we have to add those bases. So 8x squared plus 3x is one base. And then we're going to add the other base, which is 2x cubed minus x. So first, we can do a couple things here. We can do half. We can multiply this half times your 4x squared. So it'll end up being just 2x squared, half of 4. Then also, let's see what we can combine here. I'm going to write them in standard form inside here. So the 2x cubed, I'm going to write first. There's nothing else that I can combine with that. Then I'm going to go down to x squared. So we have 8x squared. Again, nothing to combine. But now we have two terms with x. So 3x minus x, 3 minus 1. So we get plus 2x. So I just simplified what was in there. Now all we have to do is distribute that 2x squared to all three of these terms. So the area of this trapezoid, we'd get 2x to the 5th, x squared and x cubed. Then plus 2 times 8, 16x to the 4th. And then last one, 4x cubed. That is simplified. We cannot combine any of those. So there is the area of our trapezoid. Now, last one, we're going to find the area of the gray, the shaded area. So what we'll want to do is find the area of the entire shape. So let's say that whole rectangle, and then we want to subtract the area of that inside rectangle. So the area of the outside, the big rectangle, is going to be length times width, so 6x times 8x minus 1. So that's the area of the big one. And then we're going to subtract the area of that inside, so we'll do 2x times 5x plus 3. So we want to distribute first. Let's find the area of our outside shape. We'd get 48x squared minus 6x when we distribute that 6x. Then minus, we're going to distribute that, 2 times 5 is 10x squared. And then distribute again, so minus 6x. And now we can go through and combine some like terms. So x squared is our highest power, so 48x squared minus 10x squared is 38x squared. Then we have negative 6x minus 6x, and we get negative 12x. So there's the area of the gray shaded region. All right, we will go over some of these examples in class to see if you're on the right track with those examples that aren't completed on here.